profit maximization in that short run when we have, we're going to have two inputs and one of the inputs is fixed. So let's say we have two inputs. We're going to call them x1 and x2. So input 1, where the amount of that is going to be x1, and it's going to be variable. And input 2 is going to be, the amount of input 2 is going to be represented by x2, and we're going to think that this is a fixed at some amount. And we're going to call that amount x2 bar. Let's say let our production function be f of x1, x2, the price of output be P, and the input prices be W1 and W2. So these are the two input prices. Remember, we were representing them by W's. That means our maximization problem is that we want to max profit. Well, profit is total revenue, which is price times output. Here, the amount of good input 2 is fixed. All we get to do is vary input 1 minus the cost of that input 1 minus the cost of that input 2 times x2. And we only get to pick x1 here, the amount of input 1. So this is like total revenue, right? It's price times quantity. This is the cost of input 1. And these are the costs of these fixed input 2. And I'm going to put actually a bar, input 2 costs. I'm going to put a bar. Remember, this is fixed, so this doesn't change. So let's make sure we put a bar on the x2s. Well, this is just a maximization problem. We're just picking x1. So let's figure out the first order condition. If we set that equal to 0, that's our profit maximization criteria. All right, so the first term that's going to come up, x1 is in this. And so remember, if we took the derivative of our production function with respect to x1, we call that the marginal product. So remember how much production change if we change x1 by a little bit? That's the marginal product of good 1. Price, the P is just a constant, so it's going to stick around. So price times the marginal product of 1 at x1 star and x2 bar. This is the maximization criteria, so we're putting a star there. And this term also has x1 in it. Here, W is just a constant, right? The derivative, the rest of this with respect to x1 is just W1 equals 0. So that means the price times the marginal product with respect to x1 equals W1. Let's think about what that means. Well, that means the value of the marginal product. When I say value of the marginal product, this is how much production is changing when we use a little bit more input 1. Right? And this is how much money we get, how much revenue we get from that little increase in production we get from changing x1. Well, the optimal amount, that revenue we get from the extra production equals the cost of using that production, of using that extra input. The value of the marginal product of a factor, here the factor 1, input 1, should equal its cost. So let's think about like labor. So let's say that's the input we get to vary. So what this is saying is the money we generate from using one more person as part of our production process, they're going to produce a certain amount more, which is the marginal product, in that case of labor, but the marginal product of that input, times the price we get to sell that extra production for. That's how much more money we get in revenue from hiring that extra person, or using an employee for an extra hour, or whatever, how many hours. And the cost of hiring that person for the extra hour is the price of that input. At the optimal amount of inputs we should use, the profit maximizing amount of inputs, the cost of hiring that person for the extra hour should equal the revenue we get from the production of that person for the extra hour, right? Which is the price times the marginal product. So that's what our maximization criteria is. And in a short run, what's different is we're just fixing one of the inputs. So we only get to choose x1. So let's erase this and kind of expand on this and think about what that is. Think about this graphically as well.